Welcome to EDU World Space.
To solve this problem using the normal approximation, we have to apply the central limit theorem, and that states that the distribution of the sample proportion, or sample mean, will be approximately normal given a sufficiently large sample size. And here we have a proportion, so we'll approximate the binomial distribution as normal. The population proportion is 40%, so that's 0.40, and the sample size is 500. The mean is n times p, which is 500 times 0.40, which is 200. And the standard deviation is the square root of n times p times 1 minus p, which would be the square root of 500 times 0.4 times 1 minus 0.4, which is 0.6. And that calculates to 10.95 approximately. And now for part A, between 170 and 220, we need z-scores for each of these. We also need to apply the continuity correction, which involves adjusting the discrete values to the nearest integer value. So for 170, we're going to use 169.5. We're going to go lower by half an integer. And for 220, we're going to go up to 220.5. Since it's inclusive, we have to go beyond. So for 170, we're actually going to get a z-score for 169.5 minus the mean over the standard deviation. And for the second z-score, 220.5. Now let's get calculations for those. About negative 2.78. And for 220.5, 1.87. So, the probability of being between 170 and 220 inclusive is about the same as the probability that the z-score is between negative 2.78 and 1.87. And we can look up both of those in a table or using a calculator. So for 1.87, it's 0.9693, and for negative 2.78, and it's 0.0027. And so 0.9693 minus 0.0027 is 0.9666, or 96.66%. For part B, fewer than 175. Again, we have to apply, since we're going fewer, we have to apply the continuity correction. We're going to get a z-score for 174.5. And a z-score for 174.5 is negative 2.33. So less than or equal to 175 is the same as the probability that z is less than negative 2.33 from the z table. And that is 0.0099, or about 0.99%, or about a 1% chance.